J-HAT 塾
Let us look at the sketch for the given problem. Here we have a triangle ABC, and we are told that AB is 8 and BC is 10. And then we are also given the cosine of this angle, angle ABC. We are told that this cosine is 4/5. Then the point M, we are told, is the midpoint of BC. So just from that, we already know that BM is 5 and MC is also 5. Then later we'll be using this circle that circumscribes the triangle ABC. Now for convenience, we will rename these sides to match the standard naming convention. That means that here the angles, for example, the angle near the point B, instead of calling that angle ABC, we're going to call that angle B. This is just for convenience. The angle here is just going to be called angle A, and the angle here is going to be called angle C. Now for the sides, the side opposite angle B will be called the lowercase b. The angle opposite angle C will be called the lowercase c. So AB, instead of calling it AB, we're going to call it C in our discussion. And likewise, the angle or the side opposite angle A, this side, which is BC, we're going to call that lowercase a. Okay, that's going to make the discussion a little bit easier. Now, let's go back to the problem and look at what they're looking for. It's looking for B. So in this drawing, B is this. So it's actually looking for AC. Now, if you look at this drawing, you notice that we have two sides, side C in here and side A in here, and we have the included angle. Now, to find this side here, we can just use the cosine law. The cosine law, if we recall, says that the square of this side equals the sum of the squares of these two sides, this one, and the square of this, minus twice their product times the cosine of the included angle, in this case, angle B. And we already know the cosine of that included angle. It's already given. So we just need to plug in those values. So this is going to be how it's going to look like. This is going to be the cosine law. And now we plug in the values that we just talked about earlier. We see that b squared is 36, and therefore b is 6. That is, this side here is 6. So we now have the answer to our first question. Our second question is, what is the sine of angle B? So notice that we are actually given the cosine of angle B. We're given that. Now we just need to find the sine of angle B. Now we have cosine and the sine of the same angle, and the way they are related is through the Pythagorean identity. Well, at least this is one of the ways that they are related. So the Pythagorean identity tells us, one of the Pythagorean identities tells us that if you get the sum of the squares of the sine of an angle and the cosine of that same angle, we should get 1. And so we just plug in the values here. We have 1. This is what we're looking for. And this one is from the given here. So we plug them in. We see that the square of the sine of B is actually 9/25. Now we only want the sine of B, not its square. So we get the square root, we get plus minus 3/5. However, we are looking at a triangle here. So in a triangle, the sine of any angle in that triangle is always going to be positive. So we're going to choose the positive value, and that's going to be 3/5. Now, for the third problem here, we are now being asked for the angle A. So if we look at this drawing again, we are we already know the sine and the cosine of this angle here, angle B. Now we're looking for this angle here. Now notice that we can use the same technique that we used earlier to find this side. We used the cosine law. Now here we can also use the cosine law because we already know this side. Remember, the cosine law tells us that the square of the side opposite this angle equals the sum of the squares of the sides adjacent to the angle minus twice the product of those sides adjacent to the angle times the cosine of this angle. So remember, we just want this angle. So in this cosine law, this application of the cosine law, we can get the cosine of that angle. So let's see how that's done. So we write, this is what we just said earlier. So now we just plug in the values. We already know A, that's already given, it's 10. B, we computed earlier in the first problem in here. So that's 6. And C, it's also given 8. So now this cosine law becomes like this. And we can see that 100 here cancels with the other 100 here. And therefore, the cosine of the angle A is 0. Now, if that's 0, the only possibility is that it's a right angle. And so we say that the angle A is in fact 90 degrees. And if we look at the drawing, it's going to look like this. This is going to be a 90-degree angle. And just looking at the circle, you can immediately see that because this is a 90-degree angle, this hypotenuse, this is a right triangle. And the hypotenuse of a right triangle is a diameter of the circumscribing circle. And therefore, BC is actually a diameter. And we can immediately see that that diameter is 10 from the given. And therefore, the radius, which is equal to BM, it's going to be 5. And MC is also a radius, so that's also 5. And also MA is also a radius, so that's also 5. So we get 5, 5, and 5, and that's a radius. And in fact, we are asked about the radius in the fourth question here. And so we already said it's 5, so we have that. Now, the fifth problem asks about the scalar product of AB and AM. So if we look at the drawing, AB is gonna be this from here to here, and AM is gonna be from here to here. Now, we recall that the dot product or the scalar product of two vectors can be computed by multiplying the magnitudes of the two vectors. In this case, the magnitude of AB multiplied by the magnitude of AM. So we know AB is 8. AM, we just said it's the radius, so it's 5, times the angle or the cosine of the angle between those two vectors. So the vectors are again AB and AM. So the angle between them is this angle here, angle MAB or BAM. So notice that is different from angle A. Angle A is 90 degrees, but angle BAM or MAB is less than 90 degrees. So that's here, right? However, we also know that MA is a radius, MB is a radius, and therefore they are equal. And what we have here is that the triangle BMA or AMB is actually isosceles. That means that this angle here is also equal to the angle here, right? The angle B is equal to the angle BAM or MAB. And therefore, the cosine of this angle here equals the cosine of this angle. And that's what we needed, right? To get the scalar product, we needed the cosine of this angle because we have to multiply it with the magnitude here and the magnitude here. So now if we write that down, we're going to get that this scalar product is the length c times the radius r times the cosine of b, because we just said that the angle we're looking for here is in fact the same as b here because it's an isosceles triangle here, right? So actually what we're looking for is AB and AM. So AB is 8, and here AM is 5, and this one is also 5 here. And so we're getting that value. Plug that back in here, and the cosine of B from the given is 4/5, and that's going to be 32 for that scalar product. Now, finally, we're going to look for the scalar product of MA and MB. Now, in the drawing, you're going to see that MA is actually this part, and MB is going to be this part. So just like the previous problem, we need to get the scalar product. And to do that, we need this length, and then that length, AM, and then the cosine of the angle here, okay? The angle BMA. Now, the lengths we already know because those are just radii. So we have 5 and 5. Now, this cosine here, we got to compute. How are we going to compute that? Now, notice that what we have here, we don't really have angles. We just have the cosines of the angles here and here. But the sum of the angles in a triangle is 180 degrees. So if I add this angle and the angle here and the angle that we're looking for, that should be 180 degrees. But we also said that this angle here is equal to the angle here because, like what we said earlier, we actually have an isosceles triangle here, BAM, right? So the angle here, which is angle B, is the same as the angle here, which is also going to be angle B. And so we have angle B plus angle B plus this angle that we're looking for, that should be 180 degrees. Okay, so if you write that down, it's going to look like this, right? 180 degrees equals 2 times angle B plus the angle AMB. Again, AMB is AMB. Okay, now we just need the cosine of AMB. So we're just gonna move this to the other side. So what we're gonna get is the angle AMB equals 180 degrees minus twice the angle B. Now we're gonna get the cosine of both sides. So here we get the cosine of angle AMB. On this side, we have this expression. Now we can use the sum of angles identity for cosine. And if you remember, so I'm just going to write that down very quickly here. If you have a cosine of the two angles, let's say the two angles are A and B, okay? It's applicable for plus and minus, right? Then this is actually equal to the cosine of A times the cosine of B minus plus the sine of A times the sine of B. Now you got to notice that if you have a plus here, you got to use minus here. If you got a minus here, you got to use plus. So in our case, we have a minus, so we're going to use plus, but actually it wouldn't matter, as you will see. So cosine of the first term, it's because it's cosine A, is 180. So that's minus 1, and so it goes here. And then the cosine of the second term, which is cosine of 2b. So that's the unknown. And then we're going to use plus, right? This is what I meant. Sine of A, but the sine of 180 degrees is actually 0. And that's why we said it doesn't matter, because the second term is just going to be 0. And so what we have is just this. So let me just clear that. I don't know how to clear this one. So I'm just gonna. So we're now left with this expression that the cosine of the angle AMB is just the negative of the cosine of twice the angle B. Now we know the cosine of angle B, but we don't know twice angle B, or rather the cosine of twice of angle B. And so what we can do here is apply another identity, that is a double angle identity or a double angle formula. And it says for cosine, it says that the cosine of twice an angle is just going to be the square of the cosine of that angle minus the square of the sine of that angle. But we already know the cosine of b from the given. It's 4/5. And we also know the sine of b. We computed it earlier, and that's 3/5. And so if you do the math here, you get that twice the cosine or cosine of twice of b is 7/25. And now we can solve for the required scalar product. So the scalar product is just the magnitude of MA, magnitude of MB, both of which are 5, times the cosine of A and B, which is -7/25. And if you do the math here, it will simplify to -7. And so our final answer there is -7.